Hey, and welcome to the video. Today I'm going to be explaining to you the 6 most common AI terms. So the 6 terms that I'm going to be explaining today are artificial intelligence, machine learning, neural networks, deep learning, AI agents, and natural language processing. Let's get started. So artificial intelligence is a computer system that can perform tasks which normally require human intelligence, like understanding speech or making decisions. So AI was invented back in the 1970s, and back then it was kind of this very stupid thing. It did not learn. It just a set of rules that could act or pretend that it was human-based reasoning. So the Deep Blue chess engine, the one that beat Kasparov in 1997, that was just a bunch of if statements, but it was kind of put together in this nice way, which made it seem that it was intelligent and could play chess, which it could. We also have expert systems in healthcare, which is basically a bunch of glorified if statements that the doctors could put in the patient's temperature and other parameters, and it would tell you, it would try to diagnose the patient. Just trying to put the knowledge of a human person into a computer. And then we also have spam filters. And back then, they were mostly rule based. So let's say if the word money appears more than 3 times in the email, it's probably spam, or we'll move it to the spam folder. So now we get to the AI hierarchy. So AI was invented, well, like 50 years ago, and it was basically just glorified instruction, no learning. But within AI, we have machine learning, which is a set of algorithms which can learn from data, and then we get to neural networks and deep learning very soon. So the second term you should know, machine learning, are a set of algorithms that let computers learn from examples and experience rather than following strict programming rules. So in normal programming, you make your rules and you get your data, and then from that you get the result. But with machine learning, you kind of flip this algorithm, you flip this equation, where you put in the result and the data, and then you get the rules. So let's say you want to be able to say whether an image is of a dog or a cat. It's kind of hard to formalize the rules for this. Let's say the data are the images and the result is whether it's a dog or a cat. And figuring out how to program this with normal programming, like what if this pixel is this value, and like just way too many things. So what you do is you just put the result on the other side of the equation, and that's what machine learning does. It gets trained and gets better with experience the more data it sees. And here's the simplest form of machine learning, which is called linear regression, which is almost like dead simple. So let's say we have these data points. Let's say the x-axis here stands for the amount of square meters inside of a home, and y is the price for that home. So generally, as the size of the apartment or house grows, the more expensive it becomes. There are other things, of course, that play into it, but it's pretty good data to have. So what you would do with the linear regression is that you would fit a line to this data. So what this basically says is that if we had if we only knew about a new house that was 30 square meters large, then with this line we could just find the x value and go up, and then we'd have a pretty good guess at how expensive that apartment would be. So that's kind of the most simple form of machine learning. And here are some examples. Machine learning can do fraud detection in banking. So what it could be is it could identify suspicious transactions based on historical fraud cases. So then it would take in data like how much time did it take to review, what are the payments like, the amount of payments per day, the average payment size, and other variables. And then you can compare that against cases where you know that it was fraud, and the algorithm can get pretty good at detecting the fraud cases. The Netflix movie recommendation system. So Netflix knows what you've watched, it keeps a history, and it knows what you like. So if it knows that you binged this sort of show, then it would probably feed you shows that look like it because it wants you to keep on watching. And also we have demand forecasting in retail, which is basically a fancy way of saying predicting how much we will sell tomorrow based on how much we sold today or over the past year. So these generally follow trends that you can predict and extrapolate from the given data that you have. Now, neural networks, they're a subset of machine learning. So all neural networks are part of machine learning. They're a subset of machine learning that uses artificial neurons to process more complex patterns in data. So machine learning is kind of basic. It can't really comprehend these really complex connections between data. Neural networks, now we're getting a little bit advanced. So the reason why it can do this is because it mimics the human brain and how it processes information. So if you consider your vision system, your eyes, they have lots of tiny receptors, billions of them, and they send information to the brain. But when you see, the experience of seeing something isn't like lots of like 10 billion like electrical signals. They've been all been filtered. So when you look out into your visual field, you see objects instead of the little pixels that make up your visual system. And this is because your neurons inside of your brain, you have 100 billion of them, they've been filtering this information and combining them into more and more useful, larger concepts like a painting, a wall, the ceiling. It looks like this. We have these neurons where the input is, let's say in facial recognition systems, that would be the pixel images of an image, let's say. And then it would process these through these layers that successively pick out the important features of the layer before them. So the second layer would maybe process maybe shapes or lines, and the second layer would maybe process complete objects like an eye or a nose. And then the output layer would be able to say if the face is yours or someone else's. So that's why it's more advanced. The second example is a voice command recognition. So let's say you have a little voice snippet, and machine learning neural networks can be trained to distinguish the play from the pause. Like a person saying play, a person saying pause. Not really any complex things, but distinguishing between these two is a pretty good task for neural networks. Also, predicting energy consumption. Let's say you have information like time, location, weather. Uh, then it becomes pretty easy to put this into a neural network, and it will be able to see the general patterns between those three factors. Maybe if the time is at night and the weather is clear, then it's going to be really cold. That means that the energy consumption is going to be high. So those kind of patterns neural networks do very well with. And now we get to deep learning. So deep learning is essentially a superpowered form of neural networks with many layers that can predict complex patterns, imitating the human brain even more. Neural networks, they're called neural networks if they have two or less hidden layers. So these are the layers that continually abstract more and more of the information. If you have three or more, then it's considered a deep neural network, which is because it can see more abstract patterns in the data. So some examples is also the facial recognition system. Possibly a neural network wouldn't really have enough abstraction to be able to distinguish two faces from each other. We can also consider AI-based art generation, where you can put in text like a dog with a funny hat, and the network is trained to create an image based on its understanding of those concepts, like a dog and a funny hat, and then can combine them. Protein folding is also a great example. So AlphaFold did this where they solve the complex problem of protein folding that would take scientists years and years to solve. And protein folding is basically you have a long string of proteins, and they have like some correct way of being shaped, being folded, and there are lots and lots of connections which you can't brute force your way through. It requires some kind of understanding, and deep learning was the method that DeepMind used to solve this problem. This network could understand the patterns between what a correct folding and an incorrect folding was, and they just ran that on the available proteins. And now we get to AI agents. So AI agents are programs or robots that can observe their surroundings, make decisions on their own, and take actions to achieve specific goals. And if we look at the image here, AI agents would kind of be in all three. So AI agents can use normal AI, they can use machine learning, and they can use neural networks. All AI agents are considered AI, but only some of them are considered to use neural networks or machine learning. So let's say you're on an online shop and you ask the chatbot if an item is available or something. What the AI agent is then able to do is that it probably has access to the database that contains all these items, and it can also formulate a response to you. So it has some kind of action, and it can put in an order for you when you call a booking site. and it can make the reservation for you. So AI agents, they use AI in ways to interact directly with the environment. Another good example is our trading algorithms. So not only do they tell you when you should buy or sell, but they can actually make the decision for you. So AI agents, they actively interact with the environment around them. And autonomous drones, of course, also a great example of this. They would use deep neural networks for computer vision to be able to see where they are and also be able to take decisions on where to fly. And then we get to the last, which is natural language processing. So this is basically technology that helps computers understand, interpret, and respond to human language, basically written human language most often. So the most intuitive example of this is the Google autocomplete. So what Google autocomplete does is that it reads whatever you're writing and then it considers what's the most likely ending or continuation of this query, because it has a lot of history given this. So it's basically machine learning, deep learning, neural networks applied to the understanding of human language. So if we get an advanced example, chatbots like GPT and Gemini, they're definitely language processing. And if you go for something more simple, you have sentiment analysis programs, which is a program which you can run on Twitter, and then you can get an understanding of the political leanings of which accounts and who they talk to. So basically, that's just understanding of the human language. Those were the 6 terms. I hope this helped you understand them a little better. So thank you for watching, and I'll see you in the next video.